My screen is visible? Guys, screen is visible?
Yes, sir.
Okay. So moment distribution method. We are going to distribute the moments. That is the main moment distribution method. This method is developed by Professor Hardy Cross. Okay, and it's like iteration method. It's not exactly, it won't give you exact solution. If you are going for many iterations,
can you please start recording, sir?
Sorry?
So can you please start recording?
I have started. I think so. No, this is started, right? It's recording only.
Yes, sir.
Okay. So this is a iteration method, like your neutron adaptation kind of thing. You might have studied in max. Like that, this is also one of the method. Okay, in structural analysis. So finally, our objective is same. To draw the surface diagram, bending moment diagram, the values you should know. So till this semester, you are trying to analyze the things. So how much stress is developed in the members, or building, or frames. So accordingly, you can design it in the upcoming semesters. So thing is, you should know how much stress is going to come to the structure. So that's why we are doing here. So many methods already you have seen in your previous semester. This semester also we are seeing many methods. So this is major methods are slope deflection and moment distribution method. And in one more subject is that is called advanced structural analysis. There you can study stiffness matrix method, flexibility method. Okay, matrix flexibility method. That also more advanced methods. So those you can study in another subject. If you are, I think that is in elective now. Who are all interested in structural analysis, you can go for it. Okay, so today, before going to this method, it's a kind of set of procedures is there like slope deflection method also. Here also we are having set of procedures. Before going to the procedures, we should know some terminologies. First one is fixed end moments, that we already know that what is a fixed moment. Whatever the beam or frame they are given, it's there. You have to log the support. That means you have to assume that the supports are fixed or joints are fixed. Due to the load, how much moments are developing in the supports. Due to the loads, how much fixed end moments are developed at the support. That is your fixed end moments. This is we have discussed many times in the fixed beam as well as slope deflection method. So next one is distribution factor. Next one is distribution factor. What is distribution factor? For example, I'm having a frame like this. Okay, frame like this. I'm going to apply some load, just lateral load. This is a bigger column. This is small column. Okay, this is a bigger column. This is small column. In applying the load, for example, some 100 kilonewton. So, can you please guess how much load will pass through these two columns? Not an exact value. For example, this is A, this is B. Which one will carry more load, or which one will attract more load? Which one will attract more load? Higher stiffness or lower stiffness? Or will load will transfer equally, irrespective of the cross sections? Who will carry more load? Okay, another example. One person is a very studious person. Okay, learned everything. Another one is not study anything. So we are putting the exam. Who will do well? Who are the study for the exam only, right? Yes, sir.
Yes, sir.
So like that, if I am having a more stiffness, very rigid body, having a bigger section, other one is smaller section, I'm applying the load. These two are connected by some elements. And applying the load, who will take care of the load? Who will take care of the heavy load? The smaller person or bigger person? Okay, another example. In your home or whatever in office works, one person is very hard worker. Is if you are giving work, he will do whatever he wants. Okay, surely he will finish it. Another one person is there. Even if he give the work, he will forget. He will finish the work maybe after 1 month only. Whom will you give the work? So who will finish the work early or who will finish the work late? Or even he forget. Whom will you give the work?
Sir, the one who finished quickly.
Quickly. Okay. So now the thing is, one person is can take heavy load. Okay, that much stiffness is having. He can carry. Another one is not at all having that much thing to carry the capacity also. So maybe less stiffness is there. Now tell me, who will carry the maximum load?
A, sir.
Bigger
Who
one.
will take?
Bigger one.
Same thing. The bigger one will try to attract more. Who are the stiffness is there. So when your elements are connecting together, that is called diaphragm action. Whatever the loads, if you are applying, it will transfer with respect to the stiffness of the section, stiffness of the member. Okay, if all members are connected together, it's a whole system. When you apply the load will share with respect to the stiffness of the member. Okay, with respect to the stiffness of the member. So A is more, you will try to take all the loads. Okay, corresponding A, he will take the loads. For example, if I am having a A, B, C. This is a joint. In that joint, if I am applying some moment, okay, in the joint some moment is going to come. Just as in. So if here joint is some moment is there, means that AB will whatever the moment is applying, that is AB, moment AB. But at joint some moment is applied. For example, some 40 kilonewton meter. At joint some moment is applied. We don't know how much moment will transfer to BA and how much moment transfer to BC. BA and BC. How much moment it will transfer? We don't know. At the joint, some moments are there. Yes or no? So how you can calculate? How will you can calculate? It is based on your stiffness of the member BA, stiffness of the member BC. Okay. So if I know the stiffness of member BA, so KBA divided by KBA plus KBC. So I can find out relative stiffness now. So this is the overall stiffness of the joint. This is also KBA, this KBC. So I just want to know how much moment is going to come for the KBA, so BA alone. So stiffness of BA divided by summation of K. Like I want to find out the BC, how much moment is transferred to BC. So KBC divided by summation of K. That means KBA plus KBC. Like what is the total? For this much stiffness, surely this much will attract. This is called distribution factor. This term is called relative stiffness. Relative stiffness, and again, if you are multiplying the amount, that is called distribution factor. Okay. First of all, I will let you know what is the stiffness alone. How will you calculate the stiffness? Okay. What is stiffness? What is stiffness? What is stiffness? Okay. Some derivations or not derivation. Some formula or some definition. What is stiffness? Yeah, you have completed mechanics of solids.
It is the resistance which a object offers to some force.
Oh, that's all. Object to offer some force.
Force per unit length.
Force per unit length or somewhat correct, 50%. Is that force per unit length? Any other thing?
Sir, flexural rigidity.
Flexural rigidity, EI, right? What is stiffness?
Yes, sir.
Okay, now can you calculate the stiffness of this beam? What is stiffness of this beam? What is the stiffness of this member? Cantilever beam. Very simple one. What is the stiffness? How will you calculate? What is stiffness of
Sir, movement
Sir?
movement resistance per unit length.
Moment resistance per unit length? No. Okay, forget about the definition. Just calculate the stiffness of this beam, cantilever beam. What is this? What is the delta displacement? How much it will become?
The
Sir,
PL
we
cube by
here
3
by
EI.
EI.
PL cube by
3 EI.
Everyone knows
3.
that, right? If I apply some P, this much displacement is coming. So
The 3
if I
EI
want,
by L cube.
if I want to create 1 mm displacement or unit displacement, forget about that. Unit displacement, how much force is required? If I am taking P by delta 3 EA by L cube. What is this?
K.
This is your K. If I am putting delta as 1 unit displacement, to produce unit displacement, how much force is required? That is your stiffness. So translation stiffness, like that you can say. Yes or no? So you know, people know the answers. First, you should know why you are studying that thing. Okay. So to produce that unit displacement, how much force is required? That is your stiffness. The stiffness of the cantilever beam is 3 by L cube. The same thing. Now, another one stiffness we can have rotational stiffness. That is translational. Now we can say it's rotational stiffness. What is mean by rotational stiffness? This is joint A, joint B. Now tell me.
Sir, M upon
Sorry?
M upon theta movement resistance per unit rotation.
Rotation. Okay, how much moment will develop here? You are applying the theta A clockwise. How much moment will develop?
So 4 E I theta A by L.
So, M equal to your moment is 4 EA theta by L at the joint. This member AB, MAB is developing 4 EA theta A by L. So if I want to find the stiffness, rotation stiffness at the joint for the AB, what I have to put? MAB by theta A, that is will be equal to 4 EA by L. So what is my rotation stiffness? To produce unit rotation, how much moment is required? To produce unit rotation, to produce unit rotation at the joint here, how much moment is required? That is 4A by L. That is your rotational stiffness, KAB. That is KAB. So when you will get the Fourier theta by father and fixed only, you will get the Fourier theta by L. So because we have done fixed, then only you will get Fourier theta by L. Here how much it will develop?
2
Here how
EI theta B by L.
A by L. Theta B or theta A?
Theta A. Sir.
We are applying only one rotation, right? Because of the moment, you are developing another moment here. Okay. So now the thing is, due to applying some rotation here, you are getting the stiffness. Okay, forget about. Another moment also is 48 theta by L. Further end also you are getting moment because you are applying some rotation. So whatever you are moments applying on joint, 50% of moment is carry over to far end. Yes or no? For example, 2EA theta A by L divided by 4EA theta A by L. What is that value? It is 0.5. So applying some moment, so 4EA theta A by L you are applying, 4EA by L you are applying, right? If theta is unit rotation means you are applying some 4EA by L moment. You are applying your moment at one joint, at the joint of one end. What is happening in far end? In far end, you had 50% of moment what you applied is developing here. That is called another one thing, carryover factor. That is called carryover factor. That we will come back again once again. So now this is the rotational stiffness, right? This far end fixer, that is 4EA by L. Now one more thing. The far end pinned. Far end pin. What about your moment? K. What about your K? How much it will be? Guys, can you hear me now?
Yes, sir.
Yes, sir.
I'm doing some network issues. Okay, now the question is, if you are instead of far and fixer, if you are having pin, what will be your K? Or how much moment will develop in this fixer support? How much moment will develop here? Just guess. I don't want to get the value. Will it be
3 EI by L.
2?
3
Okay.
EI by L.
It's 3A by L, 3A theta by L. So K will become, this is M equal to 3A theta by L. K will be equal to 3EA by L, which is nothing but M by theta. So if you derive far and pin, you will get 3A theta A by L. What about far and moment? How much moment it will transfer here? How much moment will transfer?
Zero.
Yeah, it's 0 because the pin support. No moment will transfer here. Always moment at the pin is 0 only. So this is carryover factor for far is pinned is that is 0. Carryover factor for far is fixed that is 0.5. So that is the one thing. Other thing you should know about that. Okay. So far is fixed. What is your stiffness? 4A by L. Far is pinned. What is your stiffness? GA by L. Okay. So I can write here for stiffness. Far is fixed. Another one is far is pinned. RSS simply supported. And is fixed. What is your stiffness? What is your stiffness? 4A by L. Parent is pin 4A by 3A by L. Okay. So then carryover factor. How much moment you have to? You have carry over. Parent is fixed. Then parent is in. How much? How much? Parent is fixed. How much? What is your carryover factor? How much moment is transferring? How much moment is transferring? 50% of moment is transferring. So I am just taking 0.5. Okay. Parent is pinned 0. Okay. These two things you should remember. And another one, parent is guided roller. Parent is hinge. Many things are there that we will discuss later. This is the thing first you should know today. Okay. For simple, basic thing you should know. Then we can go ahead for some complicated things. Right. So now, what are things we have discussed now? Right now, we have discussed a fixed end moment, relative stiffness or distribution factor. One joint, for example, this is a joint. B, I'm applying some moment. M, I just want to know how much moment transferred to MBA and MBC. So how can you find out? So I'm taking this as K1, this is K2. For B, the joint is rotating, Farad is fixed, here also Farad is fixed, 4A by L, 4A by L only. Or I'm just making a simply supported here also. Okay, some combination like that. So if I'm applying the load, how much stiffness, how much load it will take here. Okay, this moment I am applying at the joint, just want to know how much moment transferred to BA and BC. Okay, so how I can calculate is, so MBA will be equal to K1 divided by K1 plus K2 multiplication of M. Okay, then again MBC equal to K2 by K1 plus K2 of M. So what is K1? What is K1? If I'm saying here only applying the moment at M, B, Farad is my, for BA, Farad is fixed. Okay, Farad is fixed. So what is that K1 then? 4A by L. Then what is K2? I'm applying BC, here I'm applying the rotation, but Farad is pinned. We have to lock the joint, right? This is a fixed support. First assumption, MDM again I told you, whenever the joints are there, you have to lock and you have to make it as a fixed support. Now BC is there. Now let me know. So what is your stiffness there? It will develop here 3A by L. Right. So what is my MBA then? My MBA will be 4A by L plus 4A, 3A by L will be equal to 7A by L. Right? Then again MBC 3A by L divided by 4A by L plus 3A by L will be equal to 7A by L. Right? So this is the distribution factor. For example, if you apply some, you are getting moment at joint B, you have to find out how much moment it will transfer to BA and transfer to BC. So for that, we are having this distribution factor. Okay, so these parameters, these terminologies will be required when we are solving the problems. Okay, so I will let you know the first before going to the procedure of MDM. Before going to the procedure of MDM, I will give one more problem, simple one. Simple one. Yes. So I'm applying the moment at joint D. What you have to find out is, you have to find out MDA, MDC, MDB, and MAD, MCD, MBD. If using the carryover factor, this is not going to be exact moment, but using carryover factor, how much you will assume. Okay. So now first find out. This is one only I am asking. So applying the moment at the joint D, what about moment will DA, DC, and DB? How will you calculate? How will you calculate? What is the procedure? At the joint, we are having 3 members. We have to distribute the moment. 24 kilonewton is acting on the joint D. So that moment you have to distribute to DA, DC, DB. How will you distribute? Guys, am I audible? Guys?
Yes, sir.
Yes, sir. In proportion to stiffness factor, we will distribute.
Yeah. So what is your first one? What is your first step? You have to distribute based on your stiffness, right? So what is your first step? You have to find out KDA, stiffness of KDB and KDC. So KDA, now applying moment at this, first you have to lock the support D. It's now fixed. Right? So whatever moment applied, how much it will create here, stiffness. If one end is fixer, far end is pin, what is your stiffness? 3A by. So 3EI by, what is your length? 4 meter. Then what about KDB? Here is lock fixer, or you already locked. Again, this also fixer. So your value will be 4EI by 1. Then DC, fixer only far end, so 4EI by 5. Right? Now, what is your MDA then? MDA, KDA by KDA plus KDB plus KDC, multiplication of M, that is 24 kN. So you have to put 3A by 4 divided 3A by 4 plus 4EA by 4 plus 4EA by 5, multiplication of 20. Multiplication of 20. So like that, you can calculate MDB and MDC. Okay. So K by sigma K and multiplication of your moment. So now we can find out how much moment is distributed to DA. Okay. Like that DC. Like that DB. So finally, when you are adding all the moment, MDA plus MDB plus MDC will be equal to 24 only. Because the 24 only you are distributing with the proportional to the stiffness. Proportional to the stiffness, this much load is transferring to the members. Right? All of you clear? Guys?
Yes, sir.
Okay, now. So based on factor. Now you know that MDA. What will be your MAD? If you know the MDA, what will be your MAD? What is MAD?
0.
0 because it's pinned one. Then what about your MDC? Sorry, MCD. What about your MCD? If you know the MDC.
Minus 24. Minus 24.
50%. Now we need to put minus and all. 50% should be. So MDC by 2. So what about your MBD? MDB by 2. 50% of DB, 50% of DC will be MCD. Right? So this is our concept you should know before we are going to solve the MDM problems. Right? So these are the major things, important parameters you should know. I will just briefly tell you what is the procedure now for MDM. When you solve the problem, you will clearly understand what we are doing. Okay. First, okay, we'll start with some problem. It's simply without any value, just solving some problem. Okay. Here also some W, whatever something is there, right? Okay. Or shall we solve the problem itself? Guys, all of you are brisk, right? Shall we solve the problem?
Yes, sir.
Instead of 1, right? So what is your first step in general or problem? In slope deflection, what is your first step? We used to lock all the joints, right? I have to assume this is also fixed, this is also fixed, this is also fixed. Then I have to calculate fixed end moments, right? What is your MAB? What is your MAB? Minus WL square by 12 minus 30, 6 square by 12 is equal to minus 90 meter. So like that, MBA WL square by 12, because the fixed end moment will be due to fixity, both will try to hogging anti-clockwise. This is clockwise, right? Here plus 90 kilonewton meter. Then MBC actually is not pure MFAB, MFBA, MFBC because fixed end moments. Then this one minus W AB square by L square, so minus 40 to 3 square by L square, which is equal to minus 28.8 kilonewton meter. Then again FCB will be equal to plus W A square B by L square 40 2 square 3 by 5 square, which is equal to plus 19.2 kilonewton meter. So we just locked the supports and we found the moment. This is the first step. Okay. So what I have going to do is I'm just going to write joints alone. A, B, and C. Okay. This is a beam. What are the joints are there? A, B, C. So in A, this is joint. Okay. Now I'm going to write the member. How many members are there in A? At joint A, AB. AB only it is there. AB. Okay. At joint B, how many members are there? BA and BC. So I'm just writing BA, BC. At joint C, how many members are there? Only one. That is CB. Alright. Now my question is, if I apply some moment at B, okay, how much moment I have to transfer from here to here? Okay, that is called distribution factor. If something comes, the moment comes here, how much moment will transfer from here to here? So how will you do that? Because the here is both end is simply supported, but length is changing. Okay. So this is a thing. Keep it right. I am taking this slide now. So this is your beam. This is our A, B, C, right? So this is 6, this is 5. EA is constant. So now thing is, I want to find out how much KBA. KBA. How much is going to come? Okay, stiffness. So this Faraday spin, so 3A by L, which is equal to 3EA by 6. Okay, EA by 2. Then KBC, again it is 3A by L because Faraday spin, but length is 5. 3A by 5. So now I want to find out the stiffness, relative stiffness, KBA by KBA plus KBC, and then KBC divided by KBA plus KBC. Okay, so this is will be EA by 2. Here this will be EA by 2 plus 3EA by 5. So here 3EA by 5 divided by again EA by 2 plus 3EA by 5. So when you are doing that, you will get KBA as 5 by 11, KBC as 6 by 11. Okay, these are the distribution factors. So if for some moments are coming at the joint B, you have to distribute like that. So I can write distribution factor simply. Distribution factor distribution factor. How much for B and BC? How much it have to transfer? 5 by 11 you have to transfer. 6 by 11 you have to transfer. And A and C, no need to transfer anything because only one member is there. Water moments are coming, that is AB only. Water moments are coming here, that is CB only. So no need to worry about the transferring the moment. Yeah, sorry, distributing the moment. Okay. Now, first procedure is you have initially locked. So you found the fixed end moments, right? What are the fixed end moments for AB? What is your fixed moment for AB? Minus 90. Minus 90. BA plus 90. BC minus 20.8.8. Then CB 19.2 plus 19.2. Here, this is the initial moments we have, but we know that pin support. What is your moment? At pin support, what is your moment?
0.
0, right? But we are having some moment, right? So to make 0 here, I am going to release A and C. Release A and C. So I'm going to release A and C means this has to be 0. So what I'm going to do is, I'm going to put plus 90 here. So minus 90 plus 90 will be 0. I'm going to put minus 19.2 will be 0. Now I'm introducing some moment at joint A. Right? Now I am introducing some moment at joint A. Here I have introduced some moment at joint A. My B is fixed support. So whatever the moment, if I am introducing here, how much moment it will transfer here? How much moment it will transfer here? I am introducing moment here, right? So I am going to, because we know that pin support should be 0. So I have to release the joints A and C. So moment should not be there. That is obvious, we know that. So I'm just putting plus 90 and minus 19.2. So it will become 0. But to make 0, you have introduced some moment. So if you're introducing some moment, it has to be carry out to the far end. At A, you are applying some plus 90. So it will carry out to 50%. That is plus 45. And here at CB, here you are applied some moment. So it will carry out to 50% here. So minus 19.2 by 2 will be equal to minus 9.6. Minus 9.6. So finally, what are the moments are there now? So hereafter only you are taking initial moments for corresponding beam. So this will be 0, yes, 0. This will be 0, yes, 0 because of both are end are pin. Now here, 90 plus 45 will be 135. Minus 9.6 minus 28.8. How much it is coming? Minus 38.4. Now my question is, at joint B, what is your rule? Summation of moment at joint will be equal to, guys, summation of moment at joint B will be equal to, any joints will be equal to 0, right? That is your equilibrium equation. We have done in slope deflection method, right? Summation of moment at any joint will be equal to 0. Now at joint B, I am adding these two. What is your moment? What is your moment? Is it 0? 135 minus 38.4. How much? How much? No one has Darcy? 96.6. Is that equal to 0? Is it equal to 0?
No, sir.
So this is called unbalanced moment. This is called unbalanced moment. So again, what we have to do, we have to balance the moment. That is called balance. Balance B. At joint B, we are going to balance. How are we going to balance? will be balanced. So unbalanced moment is 96.6 is there. So if we have put minus 96.6, then only it will become 0, right? Then only it will become 0. 96.6 is there. You are putting minus 96.6, then only it will become 0. Yes or no? So the 96.6 I am going to apply at joint B. Minus 96.6 I am going to apply at joint B. So at joint B you are applying some moment, but how much it will transfer to B and BC? How much it will transfer to B and BC? That will transfer 96.6 into 5 by 11, then again 96.6 into 6 by 11 to BA and BC. Right? So this is minus, because plus 96.6 there, you have to put minus 96.6, then only your joint B will become equal to 0. So what I can put is 96.6 into 5 by 11, that is equal to minus 43.9 here, and here minus 52.7. Minus 52.7. So now thing is, you have done induce some moment. So what you have to do then? You have induced some moment at BA. What do you have to do then? You have to carry over, right? But parent is pinned. What about your carryover moment? What will be your carryover? Here in this moment here at BA, what will be a carryover here?
So 0.
Yeah, BA you are applying moment, but this is pin support, so you won't have any carryover that we have discussed earlier. Parent is pinned, carryover is 0. So 0, and here also pinned and 0. So how many iterations we are going? How many iterations we are going? That will be better to get the proper solution. Now I am just checking what about moment now. Again, final moment I am just checking. So how will be my final moment is? So here minus 90 plus 90 will be 0. So again from here 90 plus 45, 135. So sorry, this is the initial moment. This one we have done is this is over. So this 135 minus 43.9. How much it will be? Plus 91.1. Here again, this is the initial moment actually after solving everything. So minus 38.4 minus 302.7. If you are adding 91.1. So now it's all right. At joint B, if you are equating the 0, joint B, the summation amount should be equal to 0. So that is solved. This is your final answer. So instead of doing any equation, solving the equations, instead of memorizing the formula or anything, just doing the first you have to release if pin supports are there, arrive the initial moment. This is the perfect moments for the beam, corresponding given beam. Then you are checking the joint. We are having unbalanced moment is there 96.6. So we have to balance it because at joint the summation moment should be equal to 0. So to balance it, I am adding minus 96.6. So what is the meaning? We are applying some moment at joint B. So if you are applying some moment at joint B, we are having two members. So that moment has to be distributed in these two members. How will it be distributed? Based on the distribution factor. So just I distributed. Then now inducing the moment at BA. So you have to whenever you are inducing some moment, it has to carry over to the other end parent. So what about here? 0. What about here? 0. Now I just wanted to know what is my n moment now again. So 135 minus 43.9 is 90.1. Again, this is 91.1. So if still it is not balancing, unbalanced moment is there, you have to go for one more iteration. You have to balance it, you have to carry over. You have to balance it, you have to carry over. Okay, but your first iteration itself, it is successfully completed. Like at joint B, your summation of moment at joint B is equal to coming 0. We don't have any no unbalanced moment. So this is your final answer. This is your final answer. Okay. Any questions, sir? We will solve some more problem later. Any questions? Okay, guys, tomorrow and the day after tomorrow I will not be available. So we will compensate those classes later. Okay, right? I'll be on leave. We'll see on sometime. Any questions now? Today's class? No need to worry about this problem. We will do one more problem next time. Surely you will understand. But from the today's class, you should remember or you should not forget one thing is if you apply some moment at joint, how we are going to distribute to the members. For that, we require relative stiffness. And then, if you are induce a moment at one end, in fair end, surely the how much amount it is going to transfer, that is carry over. It's a fair end is fixed, 50% of moment will carry over. That is the only main things you should remember and you should not forget when you are going for moment distribution method. Okay? Okay, sir. So